Welcome to our lesson on approximation. We have already established that approximation is a way of estimating a given number in which it may not be necessary or practically possible to give the exact reading. So we approximate to give the closest possible correct value that it may be of relevance to its reading or to its measurement. So we have looked at the two principles of approximation or concepts of approximation. We have said we can approximate by rounding off, and we can also approximate by writing a number in scientific notation or standard form. So let's just go through the first principle, which is rounding off, the actual rounding off. We have already established that we can round off a number with respect to four different criteria. We can round off a number with respect to its number of significant figures. We can round off a number with respect to its place values, or number of decimal places, or the fourth criteria, rounding off with respect to the unit of measurement. So the rounding off process is based on two rules. The first rule is that first of all we identify what we call round off digit. The round off digit is simply the digit in the number where we want to retain the significance or the relevance of the value. So that is called the round off digit. So when the degree of accuracy is given, the degree of accuracy is simply the position in a number which must be retained as a relevant unit of measurement. Round off digit. So the round off digit is the last significant position that must be retained in a given number. Alright, so once we have established a round off digit in a particular number, then there is a principle which says we look at the next digit, the digit that follows the round off digit. The digit that follows this round off digit is also very important. Now, this next digit, the next digit to the round off digit, may be either 0 to 4, or it may be 5 to 9, since we only have these 10 specific digits in base 10. So if the digit, the next digit that follows the round off digit, if it is between 0 and 4, it means all these units are not of a value enough to be counted as significant in that particular number. But if this digit which follows the round off digit is 5 and above, then we consider that to be significant enough to be counted. So because it is significant enough, we normally retain the round off digit by increasing it by 1 if the next digit is 5 and above. So let's just quickly look at some examples. If we say we round off if we say we round off 1563 to two significant figures, we round it off to two significant figures. Alright, so this is the first criteria where we are saying we can round off a number with respect to a number of significant figures. So we want to round off 1563 to two significant figures. Now, first of all, this number 1563 has 4 significant figures. Since all the digits are non-zero digits, it means this number has 4 significant figures. And the most significant figure is the number which occupies the highest place value. So we can see that the 3 is under ones, 6 is under tens, 5 is under hundreds, 1 is under thousands. So the 1 has the highest place value, which means the most significant is 1, followed by 5, followed by 6, followed by 3. So if we want to round off this number to 2 significant figures, it means we want to retain this number to only 2 relevant digits. So we are going to retain 1 and 5. In short, 5 is our round off digit. 5 is our round off digit. When we say we round off to 2 significant figures, it means in this example 5 is our round off digit. So because 5 is our round off digit, we are going to look at the next digit, which in this case is 6. So because 6 is a number which is 5 and above, it is a digit which is 5 and above, it means we are going to increase the round off digit by 1. We'll get a 1 and add it to the round off digit so that it becomes 1, and then what was 5, we'll say 5 plus 1, which is 6, and the rest of the digits we replace them with zeros. So it means when we have a number like 1563, we can approximate that this number is 1600. Okay, we can approximate that this number 1563 is actually 1600. So sometimes in real life situations, if somebody says, how many people did you meet at that meeting? You can simply say we had around 1600 people, when in actual sense there were 1563 people in attendance. So that means we have approximated by rounding off 1563 to 2 significant figures. As another example, if we want to round off to 1 significant figure, let's say we round off this 0.231 to 1 significant figure. So what this means is that we are going to first of all determine how many significant figures we have in this number. 0.231, we have said since this is a decimal number, the first 0 is not significant. So the first significant figure is 2, followed by 3, followed by 1. So we have 3 significant figures. Now if we want to round it off to 1 significant figure, it means we are counting 2 as our round off digit. 2 is our round off digit. So before we estimate, we look at the next number. The next number following the round off digit is 3. So because 3 is between 0 and 4, it means we are not going to pick a 1. We are not going to increase the round off digit by 1. Instead, we are just going to disregard that 3 is not significant enough to be counted in our estimation. So it means this number is going to be 0.2. Now, you will notice that when we were dealing with the whole number, after our rounding off at 5, after adding or increasing 5 by 1, the 6 was replaced by 0, the 3 was replaced by 0, so that the number still had 4 digits in it. The simple reason is that because these 4 digits will maintain the place value of those significant figures. In this number we have said the 1 is under thousands, the 5 is under hundreds, 6 under tens, and 3 under ones. So by putting those 2 zeros where we have 6 and 3, we are making sure that the significant figures 1 and 5, which now when approximated become 6, they are maintained in their respective place values so that the value of the number itself is not lost. Now here for the decimal number 0.230 0.231, if we were to do the same as we have done in the whole number, the value changes, because we did mention that the position of 0 in decimal numbers, if the 0 appears after the last non-zero digit, it is going to be counted as a significant figure. So if we were to replace the 3 and the 1 with zeros, it means this number will still have 3 significant figures as it is in the original question. So because of that principle, we are going to disregard the 3 and the 1 and keep the decimal number as 0.2, correct to one significant figure. And this is the principle that applies when we want to round off. For example, with respect to place values, if we say we round off 7, 8, 1, 0, 2 to the nearest thousands. Let's say we round off to the nearest thousand. Now, this one is rounding off with respect to place values. We already looked at the place values that we have in the decimal base system or decimal number system, for example. So our place values, the 2 is under ones, the 0 is under tens, the 1 is under hundreds. So when we were rounding off to the nearest thousands, it means we are rounding off at 8. So 8 becomes our round off digit according to place value. So we are looking at the next digit, which is 1, and 1 is less than 5, which means we are going to disregard the rest of the numbers from 1. So the number will remain 7, 8, and then we keep the zeros so that we maintain the place value of our significant figures 7 and 8. So that will be an estimation with respect to place value. If it is rounding off with respect to decimal places, we can, for example, have 1.35899. And if we say we round off with respect to let's say 4 decimal places, if we round off with respect to 4 decimal places, or we round off to 4 decimal places, we round off to 4 decimal places, what is that going to be? Now, we already said that decimal places, these are the numbers that come after the decimal point. So our first decimal place is 3, followed by 5, followed by 8, followed by 9, followed by another 9. So our fourth decimal place is 9. So this is our round off digit. The 9, the first 9 is our round off digit. So we are going to look at the next number. Since the next number is 5 and above, it means we are going to do what? We are going to get a 1, so that we increase this 9 by 1. So when we increase this 9 by 1, it's going to become a 10. Now we cannot write a 10 because this is the decimal number system. So we are going to carry over. It means where there is 9, we'll have a 0 and carry over so that we maintain the number of decimal places. So this number is going to be 1.35. What was 8 will now become 9 because we would have added the 1, which is carried over from the addition of 1 on 9, which has now become a 0. So the 10, in short, we are going to write a 0. Where there is 9, when we add a 1, it becomes 10. So we record a 0 and carry over the 1 to 8, so that we add that to 8, it becomes 9. So when we round off here, it means this number is still correct to 4 decimal places. This number is correct to 4 decimal places as required. And then the last criteria, we have said we can round off to the nearest unit of measurement. So for example, if we want to round off, let's say 846 to the nearest 846 meters to the nearest kilometer. If we want to round off 846 meters to the nearest kilometer. Now, this is rounding off with respect to unit of measurement. Here, the unit of measurement is a meter or a kilometer in this case. So rounding off with respect to a unit of measurement, we know what happens when converting, or the relatedness of meters and kilometers. 1000 meters give us 1 kilometer. So we are looking at 846. Now, when we have 1000 units, the middle is 500. When we have 0 up to 500, or let's say 0 to 400, those will be smaller units with 5 in the middle. 500 will be considered the middle point, and then 1000. So we have already said that when rounding off, we look at the next digit. So when we look at a unit like 846 meters, 846 meters is in the upper half of the units that take us to 1000. In short, on the scale of meters that give us kilometers, 800 is closer to 1 kilometer, which is 1000. 800 may be considered to be close to 1. Okay, 800 kilometers, 846 meters will be in the upper half. So it means the 800 can be estimated to be 1000 because it is closer. It can be perceived to be closer to 1 kilometer. All right. The other way of interpreting this is to express 846 as a fraction of 1000, which can be converted to a decimal. This can be converted to a decimal 0.846. So the 0.846, those are meters. So it's like we are rounding off to the nearest kilometer. So as we have seen, the next digit is 8, which is more than 5. So it means we can round off this to 1 kilometer by adding or increasing the 0 by 1 unit, because the next digit is more than 5. So that is the idea behind rounding off with respect to units of measurement.